All right, y'all. Let's get started. So, a couple announcements first of all. I found quite a number of other readings that I thought would be good for this unit and next unit. For the immediate term, the only extra reading that you have is a blog post, which is pretty short, which I'm assigning to be due on Monday. It touches upon one topic that I talked about today, and like I said, I think it's pretty clearly written. It's from the data audit blog, which I think I've assigned a reading from before. But you'll find all on Blackboard a number of other readings, many of which are supplementals. So as usual, I'll let you know when those readings would be most helpful, and also when I'm expecting to do the required ones. You should have already gotten an email about your take-home 2 exam score. So I did actually manage to get it done a lot faster this time. So glad I was able to come through on that. So make sure you look at that. As usual, I've also posted a detailed key, and I tried to give you slightly more detailed feedback this time too, because I was sort of feeling like the amount of individualized feedback, it takes some time to do it, but it's a little bit on the low side for my taste. So as usual, if you have questions about any of that, feel free to make an appointment with me, come to my office hours, whatever you find the most useful way of getting in contact with me. One last announcement. I'll be covering drill tomorrow. I think Austin has probably already told you that. So anyway, you have more of me for whatever that's worth. Note on take-home 2, I've shown you correlation tables like this before. This is a way of checking for construct validity. If you remember way back when, last semester when we talked about construct validity, we talked about assessing whether things are related to each other in sensible ways. And I think the tests seem to have good construct validity, especially the take-homes. They're tend to be more applied. They're strongly related to each other. The class is a little different. It's more conceptual. On this take-home, by the way, I thought scores were really good. I was very pleased. I thought you all did extremely well. There were a couple questions, or a couple issues rather, on the graph in particular. I noticed that some people were struggling to create that graph. One of the issues, I think, was that, I think many of you did not end up using predict. Instead, in the past you've often used ggpredict, and this plain predict function is first a little bit differently from other functions. So that's one place where you can look to key for one way to construct the graph. Another thing that came up actually was that if you try to plot the points for the generalized linear model, it ends up obscuring the predicted values, the point estimates that you get from the model. And I think actually for this particular graph, if I were presenting this in a paper of mine, I'd probably present the odds rather than the raw points, because the probabilities that we got were pretty low, since these are callbacks, so it's pretty low for any given resume that you send out, and you have a low probability of getting a callback. So a lot of the probabilities were in the 0.08 range, which is pretty low. It was hard to see any differences in callbacks. So I think the odds ratio, plotting the odds ratio made a little bit more sense here, but I didn't take off if you made the probability plot. That was perfectly fine. So again, I do urge you to look at the key to see what that might look like. There were a couple issues as well on the write-up. I thought you all did quite well on the write-up, but one thing that was often missed was providing some detail about the model that you did. So I think that should go in any write-up, because you want to give people enough information to know what exactly you did. So saying things like we could generalize the linear model, or saying logistic regression would have worked, talking about the coding scheme that you use, and giving specific details about that coding scheme. Those were some of the things that I thought you could have improved with the writing. But otherwise, I thought you did really well. Very pleased. I feel like I continue to see improvements in what you're able to do. I'm very happy about that. I also took a look at the course evaluations. So thank you to those of you who filled this out. Thank you for humoring me throughout this entire process. It's more course evaluations than is usual, I think. But anyway, now that we have 4 of these, we can look at some long-term trends on some of the responses. So one thing that I'm pleased to see is that, according to the people who did respond, clarity of the lectures is improving. I actually think that this improvement says more about your understanding than about my improvements. I think this is another indication of learning and the fact that some of these concepts are starting to solidify. And a few of you mentioned that in your written responses too. So I'm pleased about that. In terms of the clarity of the drills, seems like the responses are about the same, slight decline over time, but not by that much. I don't know that there's anything, or I don't have any particular interpretation of that. In terms of the pacing of lecture and drill, a lot of you are still saying that lecture is a little bit fast, and mentioned this a couple times, but that's somewhat deliberate. The fact that I want to get through a lot of material and also push you a bit. One thing that's quite interesting is the perceived pace of the drill has continued to decline, and this is actually pretty remarkable. So at the beginning of the fall semester, the average response was up at 6. Now it's about a 4, which on the scale means just right. So this is another indication of learning, I think, the fact that what seemed really hard and like a lot of material to cover seems really manageable now. So I want you to look at that, think about what it means, and appreciate the fact that you've done something pretty tough and have continued to learn and continue to get up to speed. And I think that's really great. I'm very pleased about that. In terms of your confidence in R, this is another place where we've seen continuous improvements, going up from a 4, which is to a 5, which is okay, I'm pretty comfortable. And some of you are up at a 6. So again, I think this is connected to that perceived pace of the drill section, the fact that we're also starting to experience a bit more fluidity, a bit more comfort with what you're doing now. So that's great. In terms of evaluations of the course overall, evaluations of the course overall have improved a fair amount. Evaluations of me have, well, started out at a 5 and ended at a 5. But this is something that we've seen throughout, is that what you think about the course is remaining pretty steady. Although what's most important to me is the fact that things that once seemed pretty fast now seem less fast, and you're experiencing more comfort in actually doing statistics. That's the whole point of this class. So for me, I'm very heartened by this particular evaluation. A couple of you mentioned something that a few things I could do to improve. So one thing that came up is organizing this bank of materials that I've given you a little bit more. I think that's a great idea. I don't think I'm able to do it. There's just too much for me to do, and frankly, I'm having trouble keeping up with the class as it is because I'm doing so much that's new. I do think it's a great idea, though. I guess one thing that I'll urge you to do is, if you want to be able to reference other materials back in the course, you can think about, we had this whole unit on like organizing projects and managing data. So I encourage you to think about those principles, try to organize things in the way that makes sense to you. So be active in how you're curating materials so that you can access them when you need them. One last thing about the course evaluations. Many of you, most of you actually said that these new units that we did were quite useful, and I'm happy to hear that. So that's one thing I do want to change for future iterations of the course is have the data management unit come earlier. I think that would be probably pretty helpful for you guys. And when I thought about doing it, I thought at the time, like, we should have been doing this really early. So yeah, I think it's a good idea. It's a change that I'd like to make in the future. So thank you once again for humoring me with these course evaluations. They've been super helpful to me. And you know, I've been using them every time to make improvements. And yeah, I've even used these to change the structure of the course. That's why we had that unit on data management. So it's been really helpful to me. Appreciate it. All right, so let's get into the meat of today's lecture. We're going to be continuing on with this unit on repeated measures. But we're going to we're going to be talking about something slightly different from the last three classes. The last three classes have been focused on the mechanics of doing the repeated measures analysis. Today we're going to be talking a bit more about the why, and also a bit more about how parts of the repeated measures analysis come together, like what's happening under the hood. We're not going to talk about the formal model behind it just yet. That's something that we're going to get to next week. But we'll talk more about how these like random effects, these things that we've been discussing, like how do they actually work and what do they do to them. So often when you're like designing a study, when you're thinking about how you want the pieces of the study to together, you have a choice about whether to use a repeated measures style design or a design without repeated measures. So to illustrate this, let's think back on one of the iterations of this like grant evaluation study that we talked about. So one of these iterations, we had 50 people each evaluate 4 grants. So they gave an evaluation to all 4 of these. They gave ratings to all of them. And each of the grants was slightly different. So we had one low quality grant with a female submitter, with a male submitter, and those 2 same conditions with high quality grants. So each person gives 4 responses. That's one possible design. However, as if we're like at the design stage and thinking about how we want to implement a study like this, we could choose a different design. So instead, we could have 50 people each evaluate 1 grant, and the grant could be selected out of 4 possible conditions. So that would give us a total of 200 people, and they would only give us 1 rating. So 2 possible iterations of the same study. In one, we have 50 people giving 4 evaluations, and in another, we have 200 people each giving 1 evaluation. So what I want you to do actually is divide up into small groups of maybe 3 or 4 people and think about these 2 possible designs. One where you have 1 person giving 4 ratings, another where you have each person giving 1 rating. And think about one, what might be some reasons to prefer that first style of design, and 2, what might be some reasons to prefer that second style of design. So think about the strengths and benefits of each. So divide up groups of 3 or 4 people, answer these 2 questions.
Yeah, it's an idea. My idea is to design.
I like the ones who more people value it.
Yeah, I was excited about it.
It is more expensive, but you have, has a higher reliability between the guys.
Is there
So having people evaluate.
The not within, the second officer. Yeah. I think the one person is higher power. Higher power. Yeah. Yeah, how is one to do person looking at four yeah, you can see gender effects. And quality.
I think what you can see in the other ones too, is just. Like his other tongue here.
Yeah.
Yeah, it's kind of how it's like, it's possible to do that.
I think the second one, since we've got to learn they're on the second group.
So you would consider your
Yeah. You know what I mean?
It's within the same.
As you're answering these questions, think about what it would be like to be a participant, a reviewer in one of these two studies. That might help you think about strengths and weaknesses of each. As you're answering these questions, think about what it would be like to be a reviewer in each study. That might help you figure out strengths and weaknesses. What would it be like to evaluate those strengths?
Yeah.
Yeah.
So as a researcher, I can. Because you get into that.
So then you would have to have be a whole nother company. Yeah, never be more traditional.
All right, discussion's starting to tail off. What's a reason to prefer design in one? Yeah, so resources, that's an interesting question. On the one hand, you have to recruit fewer people, so 50 versus 200. But on the other hand, if you're, let's say you have to pay these people, you still might need to pay people an hourly rate. So it kind of depends on how much more effort it takes to evaluate each extra grade. You might have a cheaper study overall. That It depends. It depends on the cost of improvement. It depends on how much longer it takes to do the study. But in general, yes, I agree. And in terms of people, at least, you get more out of each person. It's making more efficient. Great. What's another reason to prefer design blended?
I think it's interesting to see like how one particular reviewer can rate 4 different people, and if it's really varied within one single reviewer. That would be kind of, if that's the point you're trying to prove with the study, that no one is good at it.
Right. So that's a really interesting idea. Being able to say that one person changed their behavior across conditions, or to make statements about what one person did, aggregated across a bunch of people, but you have that one person getting multiple responses, and that maybe has some benefits of being able to make statements about one person and their behavior, their changes in behavior on average. Yeah, great point. I agree. Okay, how about design 2? What might be some reasons to prefer design 2?
We came up with this thought that maybe in design 1, the ordering of the grants that they rate can kind of bias their ratings of the next subsequent grants.
Yeah, so let's imagine that, I don't know if any of you have had a chance to do reviews of papers. Has anybody had that experience yet? Still a little bit early in graduate school, but you certainly have the experience of reading papers and evaluating them. If you're doing a batch of them and they're all a little similar, you can imagine, like, sort of get the idea of how to do it on the first one, so your ratings won't be like a little bit more arbitrary or a little bit more harsh or even a little bit more lenient, but then they kind of tail off towards the end. So behavior early might be different from behavior late. But also, it could be that having an experience of creating, say, a low-quality grant could affect the experience of rating a high-quality grant. Suddenly, the high-quality grant looks a lot better, just by contrast from the low-quality grant. Great.
Could you avoid that by counterbalancing them?
Absolutely. We'll talk about this in a little bit more detail later in this lecture, but one way to counteract that, to cope with these order effects, is by giving different orderings to each person. There's a particular way of doing that called counterbalancing that usually works pretty well. What might be another reason for design 2?
More diverse sample of people.
Oh, that's an interesting one. So the mere fact of having more people means that you can have more different types. Absolutely, I completely agree.
Along those same lines, though, we were kind of saying that maybe you might have a lot of individual differences among your groups of people for design 2, so that might introduce some variance.
Yeah, and can you be a little bit more specific about what you mean by individual differences?
Sure, yeah, so those first 50 people may hate rating grants, and the second people may love rating grants.
Okay. Yeah, so I agree that individual differences does play a consideration in these designs, but it might not be in quite the way that you're describing. It's going to be hard for me to describe why this is until later on in the lecture, but hold that thought, individual differences is something that plays a role. So I agree with an aspect. Any other thoughts?
We were talking about power, but we all agree that we don't know how power works with repeated measures. So we thought maybe the second one might have more people. But
Yeah, these are different designs, right? So it would make sense that one of them might be in general more powerful than another, or maybe it depends on some set of circumstances. Depends on something actually. So yes, each of these designs has different amounts of power, and that might affect whether you choose one design or not. We will expand on that point in a bit. Good.
So the goal
yes,
is
go
to
ahead.
see differences between ratings of male and female. So like what's the goal of this thing? I forgot before.
Yeah, so there might be multiple goals, right? You might want to compare on average, how do people rate high versus low quality grants? Maybe you want to see whether there's gender discrimination, so do they give different scores to male versus female guys? You might also be interested in whether that size difference between male and female guys changes depending on whether you're rating low quality grants or high quality grants.
So is the possibility it's going in the middle, like having 50 people evaluate the first two conditions and then having another 50 people evaluate the last two conditions? Is that like a possible state?
Absolutely. So we could mix these two types of designs, have repeated measures on one of the variables, but not repeated measures on the other. So, for example, have everybody rate both a low quality grant and a high quality grant. So that would be the repeated measures. But say half the people get male grants and half the people get female grants. You can certainly do lots of iterations of these different kinds of designs. And that is one of the central questions that you have to think about as you're choosing to do repeated measures. Absolutely. Cool. Yeah, so I agree with a lot of those comments about reasons to choose one versus another. So one of them that you hit on very early is that there's this pragmatic consideration about how the repeated measures design doesn't force you to go out and get as many participants. Whether that ends up being more costly in terms of dollar or person, yeah.
Would you call the second design just between subjects?
Yes, that's one common term, fully between subjects. Another common term for this design, the design one, is fully within subjects. Although I've been using the term unit because you don't have to have repeated measures on subjects all the time. It could be on schools or businesses or even grants. So each grant could be seen by multiple people. So you can think about repeated measures as applying to lots of different types of units. But in psychology, in the social sciences, most often you see this concept applied to disciplines within subjects versus between subjects. Absolutely. Yeah, so there's this pragmatic consideration. One of these designs forces you to get more participants. And that might end up being more costly. It certainly is true that the design is more efficient in that you get more out of each participant group. Although if you get a lot out of one person, you might have to pay them a lot. So that's one axis to think about. Efficiency, how much you're getting out of each person. But for the others, one way to think about trade-offs and having repeated measures versus not is to think about the dimensions of validity that we talked about way back last semester and then cropped up several times since then as well. So stretch your memory a little bit. What's one type of validity that might be affected by the decision about whether to get repeated measures? External validity. Do you remember what external validity is?
Is it being able to generalize out to the broader population?
Absolutely. So external validity, that's one of them. Can you generalize from your setting or measure or population to another? Generalizability. Yep.
Internal validity,
Internal validity. And do you remember what that is?
the extent to which you can be confident that your IVs will cause changes in your gene.
Your ability to make causal inferences. Remember we had a whole unit about causal inference actually. So internal validity, that's another type of validity that might be affected by these things. Great. What's another one?
I guess construct validity,
Construct validity, great. And do you remember what construct validity is?
how well you're experimenting.
Are you measuring the thing that you think you're measuring? Absolutely. And then there's one more.
Is it ecological?
We didn't talk about that in this class. The ecological validity is the extent to which what you do in your study matches some real world setting. Very strongly related to external validity. This last one is related to a particular statistical concept that comes up when you're making inferences about free percent estimate. Conclusion validity. Do you remember what that?
Vaguely, I don't know if your like results like make sense.
The way I like to think about it is, are you able to draw any conclusions at all? Another way to think about it is, how noisy is your study? Do you have a lot of noise, or do you have very little noise, which allows you to draw conclusions pretty easily about the presence or absence of an effect? So we have these 4 types of validity: external validity, construct validity, internal validity, and conclusion validity. So one way we could think about the trade-offs of repeated measures is just go down to certain types of validity and ask the question, does the decision to have repeated measures on something affect the type of validity? So let's think about this first one. Do you think that having repeated measures affects external validity at all?
Fewer subjects.
It's possible. If you have a lower variety of participants, maybe it affects this. I think overall, usually it won't affect your external validity. Maybe in that way, but if you're sampling from the same population, your sampling method hasn't changed if you have repeated measures. So maybe it's possible. I think in general, though, it probably won't. But maybe under some circumstances. What about construct validity? So this is, are you measuring the thing that you think you're measuring?
I think so.
Can you give me a specific example?
Well, with this example, you don't deal within subjects, it's hard to say that you're looking at the same thing.
Yeah, so that's one thing that we mentioned. Change that you see within people might not be the same thing as differences between people. If you want to think about like why that might be, let's imagine that you're doing a study on depression. And in one version of the study, you look at how depression varies between people. In another, you look at how depression varies within people. If you're looking at how depression varies between people, well, there's a lot of other stuff that could also vary between people besides depression. But if you're looking at how depression varies within people, well, people's life events might change, but that seems like a slightly different type of question. It seems like it gets you a slightly different answer, it allows you to draw conclusions that you couldn't if you're looking at things between people. So in general, you're not guaranteed that processes that occur across people are going to be the same as processes that occur within people. Absolutely. Any other way that construct validity might be affected? Let's go back to that question I asked about the 4 grades. Imagine that you're asked to give ratings to either 1 grade or 4 grades. Let's further imagine, so in my experience reading and writing reviews on papers, I'm a little bit slow at this. If I'm trying to do a good job, it'll take me maybe half a day. Maybe I can get that a little lower, but in my experience, it just takes half a day. So let's imagine you're asked to do that once versus 4 times.
Well, I guess this ties like a little bit into inclusion validity, but you can have some more like noise, like they might be comparing if they're doing for one grant to another. And so that could be affected. You could also, if you were saying time gets thrown in there too, to another effects.
Absolutely. So how do I know that my measure of quality or my rating of this grant is the same at the beginning of the study versus the end of the study? Maybe that measure of my rating of the grant gets a little bit noisier and isn't actually a true measure of what I think about the grant, just because I'm freaking tired, or I'm sick of the study, or I've already evaluated 3 grants, or there could be any number of reasons why my experiences early in the study can affect my experiences later in the study. This actually ties a little bit into the next type of validity too. But the general question to ask yourself is, does the experience of measuring something early affect the experience of measuring that same thing later? So in general, with construct validity, I think you can ask yourself 2 questions about whether it makes sense to do repeated measures or not. One is, does extra observation change the relationship between construct and measure? That's that concept I was talking about how maybe my ratings after rating 3 grants might not be as closely tied to what I actually think about the grants, just because I'm tired. And then there's the second question that you all hit on too, which is, are you sure that the processes that occur between people are the same as the processes that occur within people? Great. And just to be clear, with all of these questions, or with most of them, I don't have definitive conclusions for you. These are things to think about. And I also have some suggestions for coping with these issues. But I'm not trying to present you with the answer. All right. How about internal validity, the ability to draw causal inferences?
This is similar to the last one.
Can you say more?
In regards to how you have one person rate 1 versus one person rate 4. Same.
Yeah, so one way to think about this, in the full version of this design that I haven't talked about yet, there are rates by white males, rates by white females, rates by black males, and rates by black females. Let's imagine you're a reviewer, and one of the PIs is named John Smith, the other is named Jane Smith, the other is named Darnell Washington, the other is named Letitia Washington. What do you think the study's going to be about?
Racial bias.
Yeah, you're probably going to have a shrewd guess about what the study's about. So in other words, the experience of being in one of the conditions might affect the ability of the other condition to do what it's intended to do. These are, one way of thinking about this is that one condition can contaminate another. This is often called contamination. Another way this can surface is through order. In order to, you can only experience one thing at a time usually. Some manipulations you can present them simultaneously, but often you have to experience things one at a time. And the order in which you do them can affect your behavior on subsequent iterations of the task. So this is the idea that I mentioned before about how if you rate a high quality grant, maybe the low quality grant that you rate next seems extra bad by contrast. That's often called a contrast effect. It's part of the same idea that being in one of the conditions can affect the experience of being in one of the other conditions. And to the extent that that happens, it affects your ability to actually draw conclusions about, say, how the race of the principal investigator affects people's ratings, or how the gender of the principal investigator affects the ratings. You can't draw strong conclusions about the thing that you want to, causal or otherwise, because of these contamination effects. There are a couple of common ways of dealing with this problem of contamination that I'll touch on briefly, because they're handy tools to have in your tool belt of design principles. One of them is to build in breaks. So you give the student a chance for whatever manipulation is to dissipate. You try to build in some time so that the effects of the manipulation disappear. This is not a cure-all, because one of the things that might be unknown, actually, is just how long the effects of a given manipulation last. But it is one way that people deal with this problem of contamination. You just build in breaks. Another way is by actually changing up the order that each participant proceeds. This is a principle called counterbalancing. And to get a sense of what this looks like in action, let's imagine that you have 6 people, and they can each experience, they're each going to experience 3 different conditions. So the first person gets condition A first, then B, then C. The next person gets A, then C, then B, and so on, down all possible orderings of conditions. So you're making sure that if there is a contamination effect of A on B, you've got some people who don't experience that experience different ordering. This is not perfect either, because if A affects B, well, that's going to happen for any person who experiences A then B. But it's one workaround. And another thing that you can do is actually use order as a between subjects variable. So you just add it to your model and control for those order effects before you test any sort of effects that you're actually interested in. That's not quite perfect either, because controlling for something doesn't always completely remove its effects, but it's one common workaround. Questions on this?
In a situation where your order does have an effect, what do you do then? They just want crap.
If you're really worried about order, maybe you shouldn't be using repeated measures. Like I said, these are workarounds, and they can, if you're not worried about repeated measures or contamination, but you just want to be sure, this is one of the ways that you can be sure. If you're really, really worried about it, maybe repeated measures is in the way to design your study. This is one of those trade-offs to balance when you're at the design stage. Does that answer your question?
So, repeated measures and like a fully between design, like they're not aimed towards solving the same type of problem, right? Like you use them for different goals.
There are certain things that repeated measures does really well that non-repeated measures doesn't do as well, especially related to conclusion validity, which is the last thing I want to go through. It's also, it can be an open question whether if the between subjects or the fully between version of the study gets even at the same question as the fully within one. Because there are these examples where, maybe the processes that are happening within a person, like their trajectory of depression, is just different from how people vary across each other. So I guess my answer is they can be getting at the same question. They don't have to be getting at the same question. And yes, the two designs do serve different purposes. I'd say in general, the between subjects design, it eliminates this problem of contamination. That's one of its really big draws, one of the biggest reasons to do it. However, the repeated measures version of the design has its own strengths as well. So it's not like one is always better than the other. Other questions? So the last type of validity to think about is conclusion validity. And it is often the case, maybe even usually the case, that repeated measures designs will be more powerful than designs that don't have repeated measures. And when that's going to happen depends on this new addition that we've touched on a bit, called the random effects. You do those little regressions, one for each person or unit that you have in your design. That procedure is something that can help increase your power or conclusion validity. So to see why that is, I've got a couple graphs to help illustrate this visually, but I'll give you a sense of what the considerations are. So let's imagine that we're working with a simpler design, another one that we've talked about in this unit, where each person evaluates a low quality gradient and a high quality gradient. And in one version, each person does both of those, and the other one person does each of them. So we either have, say, 50 people each evaluating 2 grades, or 100 people each evaluating 1 grade. And just to show you what the structure of the data looks like, we're going to be working with the same data set, but in one version, we have each person gets 2 rows, and another version, each person gets 1 row. So in the version of the design without repeated measures, the way we approached this kind of study was you plot quality on the x-axis. You find the regression line that fits the data best, that minimizes the sum of the squared errors. And when you're done, you have a certain amount of error left over. And that amount of error can be used in order to draw inferences. You compare the effect to that amount of error to say, like, can I reject the null hypothesis or not? In the repeated measures version of the same design, we broke apart the data set into 50 different chunks, 1 per participant. And we then use each of those chunks to do the same process where we fit a little miniature regression for each person. We extract parameters for each person. And then after we're done, we do that second stage of analysis on those extracted parameters. So I can show the same data set with the changes across each version. So the same point, I'm showing the same points here and here. It's just that here I'm showing how sets of these points are linked. They're linked in the sense that they come from the same reviewer. The same scientist gave both of those measurements. So the data structure is the same. I have the same sequence of ratings, 1, 9, 3, 5, whatever. It's just that in one version of the data set, I can draw these links, and the other version, I can't. That linkage is really important because that's the thing that determines whether a repeated measures design would be more powerful. So one way to see, like, what's the leftover error, what am I not explaining in these ratings, is I can subtract out that the difference in quality across low and high quality grades. So what I'm doing is I'm literally just removing that line and moving these points down and these points up, because the low quality grades are rated a little bit worse and the high quality grades are rated a little bit better. And then I can squish those points together, and this is the error that's left over. This is what I'm not explaining from this data set. Are people following so far? Yeah.
Why is that what you're not explaining? What do you mean?
The slope of this line represents the quality difference between, or the rating difference between low and high quality grades. What I'm doing is I'm subtracting out that rating difference. That's the thing that I can explain by whether the grades are low and high quality.
Oh,
Anything that's remaining is something that I can't explain.
okay.
Does that make sense?
Yeah.
So this is the error that's left over in that between subjects design, the one that does not have repeated measures. But when I'm looking at this other design, I've got these extra links that between points that I have to deal with because they come from the same review. So I have to go through a stage where I remove the part of these points that does not have to do with the quality difference. And that is each individual reviewer's intercept, their average rating that they gave to 2 grades. So I have to subtract that out first before I do anything with the quality difference. So what I'm doing here is I'm just subtracting out each person's individual intercept. That makes sense? I can then also subtract out that overall quality difference. So I can remove that black line. And this is what I have left over when I go through that process. I smush those points together, and this is the variation that's unexplained. The variation that I don't know why people varied on their ratings. Notice how the spread in these points is a lot larger than the spread in these points. That's because I was able to remove the average rating that each person gave to their grades. I was able to say, well, this person was a little bit more harsh on their grades overall. This person was a little bit less harsh than average overall. I was able to equate those people before I looked at the difference between high and low quality grades. That is that power benefit that you get from using repeated measures. You're able to remove why one person is different from another before you look at the quality difference. One way to think about it is that if you give each person low quality grades and high quality grades, you allow each person to service their own control. So you're able to remove, I'm a particularly harsh reviewer, so I'm just going to give all the grades bad scores. You're able to remove that effect before you look at any manipulation that you are interested in. And the removal of, I'm just a particularly harsh reviewer, that's why these points are less spread than these points. It's because I was able to go through this step right here. questions on that? One important idea here is you can think about the interpretation of what it is that you're doing when you're removing those individual intercepts. Those intercepts represent why, well, I'm a harsh reviewer, I just have more negative reviews, or I'm a less harsh reviewer. They represent, on average, the variability, the intercepts, and the fact that I have a higher intercept on average than some other reviewer. It's this idea of allowing each reviewer to serve as their own control, to compare each reviewer with himself before you look at other effects. Another important idea here is that to the extent that it is true that you have some reviewers that are consistently more harsh in their ratings than others, that is going to be proportionate to the power that you gain from doing repeated measures. So if you're working with in a domain where there are really large individual differences between reviewers or companies or whatever, that's a domain where you might want to think really seriously about using repeated measures, because you'll be able to remove those large individual differences before you look at whatever effects that you're interested in. So that gets back to your point about individual differences. Actually, a domain where you have large individual differences that are not what you're interested in, that's a place where repeated measures and gain would be better. The reason for that is that we're able to shrink the spread of these points, the spread of these errors, by removing those individual differences before you look at your effects. What you're doing is you're taking advantage of the links between points. The fact that some points have a dependency in that if I know the error for reviewer 1, that might tell me something about their error on another observation. Oh, this is a really harsh reviewer, so if they gave a worse rating than average at one point, they'll probably give a worse rating than average on the second point as well. Another important point here is that if you are working with data that have those kinds of dependencies, you're not allowed to AOS those as if they're totally different subjects. But you have to respect the interdependence between units. If you're measuring pupils in different classrooms, well, pupils from the same classroom are probably similar to each other, so you're not allowed to just ignore that if it's convenient for you. You have to do it. But at the design stage, this is a place where you can make choices. You can choose to design your study in a way that has repeated measures or doesn't. So the things to think about as to whether repeated measures will give you this power boost are, one, the amount of the size of those like individual intercepts, or the size of those random effects that are different from the effect that you're actually interested in. So that's what you're able to remove from your error term before you look at the things that you're actually interested in. The larger that is, the more your power gain. And then the second thing has to do with the fact that if you have repeated measures, suddenly you have observations that depend on each other, which means that it's not really fair to count the 2 rows from participant 1 in that first data set as 2 separate observations. Actually, they're observations that have some dependency on each other. They're not fully 2 different observations. And in fact, the procedure for doing this like taking these individual intercepts and slopes, notice how we take what used to be 2 rows and compress it into 1 row. And in fact, what we're doing is we're saying, no, these are really one observation. I have one intercept from that person. I also have a slope from that person. But the fact that 2 rows becomes 1 says that it's not really fair to count those as 2 separate observations. They're 2 observations that come from 1 person of shared dependency. So the second thing that affects how much power you have is how many independent chunks of information that you actually have. In the examples that we've gone through so far, the number of chunks you have is equal to the number of units, so participants or companies or whatever it is that you're interested in. But we are going to get to more complicated examples where it's a little bit more difficult to work out how many chunks of information you actually have. Yet there's a computer program that does it for you, but I'm sort of forecasting that this can be a complicated problem. Yeah.
Would you be able to maybe give a visual example of that first issue? How we can like that spread be different? How that would reduce them?
Sure. So I have a cloud of points, but if I look at any one of these points, this might be the slope for person 1, this might be the slope for person 2, this might be the slope for person 3, and then if I take the average of those 2, all of the intercepts end up being close to 0. That means that the intercepts do not vary all that much. If I take 1 person, it's just not true that there are some reviewers that are particularly harsh or not very harsh. Everybody, they just rates what's in front of them. There's not a strong individual tendency. So that might be a case where you don't get as much benefit from repeated measures because when you subtract out that individual tendency, so you move these points close to 0, they just don't move that much. I still have slopes that go all over the place. Does that make sense? So we go back to some slides that I showed you where I compared the between subjects analysis to the within subjects analysis, the repeated measures analysis to the non-repeated measures analysis. Notice how we have the same slope for quality, but our p-value for the repeated measures analysis ends up being a little bit lower. That's that power gain that you get from being able to subtract out people's individual tendencies to be harsh or not harsh in their ratings. And the degree to which that p-value ends up being smaller is going to be proportionate to this value right here. That's that variation in the intercepts. The intercepts are people's tendencies to be harsh or not harsh in their ratings. So the larger this number is, the more you'll get that power boost. But notice you also pay a penalty for having a repeated measures design. Here we have 49 degrees of freedom because we have basically 50 individual regressions that we fit, which gives us a data set that has 50 rows. Whereas here we have 100 observations if we're treating them as fully independent. So those are those 2 factors that you can see in action. So again, the thing to ask yourself is that assuming I have the same number of rows in my data set, is the cost that I pay by reducing my degrees of freedom worth the benefit that I get from being able to reduce my error, being able to remove individual differences? There's a special case of a repeated measures design that should be analyzed in a particular way. I'm not going to get into it in detail in this class. This is what the blog post covers, and there's also a supplemental reading that covers this case too. The reason I'm covering it is that it often comes up in the social sciences. And that's where you have repeated measures on some outcome. Let's say that you're analyzing purchasing behavior, and you have purchasing behavior at some early time point and some late time point. And then you do some sort of manipulation that does vary between subjects in between. And what you're interested in is the effects of that manipulation. So this is a case where you have repeated measures on purchases. Maybe time is that variable. It turns out that in most cases, the model that's going to give you the best statistical power, best conclusion point is one where you're using a wide data set and you use the pre-manipulation purchasing behavior as a covariate. I'm not going to get into why, because this is kind of a special limited case. That does come up a reasonable amount. Instead, what I'm doing is giving you some references that describe why, including that blog post that I've assigned. And there's also a paper that you can read and reference that basically makes this point. So this is not terribly important for this class, but I do want to make you aware of it because it does come up, and it's come up in my research too. So these are the different types of validity that could be affected by having repeated measurements on something. And like I said, I think that for most of these types of validity, there's not like a hard and fast rule for how repeated measurement will absolutely affect that type of validity. It really depends on your content domain. But these are some considerations. These are some things to think about when you are designing your studies. In general, the biggest trade-off, I think, is between power, because it will usually be the case that having repeated measurement will give you more power, and internal and construct validity. So repeated measurement is really good for power. It can affect internal construct validity. Having between subjects measurements is often better for internal and construct validity, but it's a lot less powerful. Often. I want to touch briefly on graphing and writing these kinds of models. So one way that you can graph these models is to treat them just as you would a fully between subjects design. Just plot all the points, give the predicted values and some standard errors, and you already know how to do that. But you have some additional options that are granted to you by the fact that you have these links between some of the points. I'm not going to give you an exhaustive list of all the things that you can do, but just show you some options. So one is to draw these individual lines representing, the individual prediction line for each person. This plot can be a little bit noisy, visually noisy, hard to interpret, but it does provide that extra information that is really important for this kind of design, which is which point is linked to which. If you're doing that kind of plot, often I think it's a little bit better to show a linked line representing the overall estimate, the fixed effects. And with this kind of plot, you could also plot an error band around that line but I don't think it's necessary to really have some information about error on these individual points. And actually, one thing you can do too to make it less visually noisy is just remove the points, because you already get that information via the lines. This kind of plot has a particular name called a spaghetti plot. It's kind of a funny name. Spaghetti just is, where they cross lines. I like spaghetti plots. I think they can be really useful in some circumstances. One little bit of extra R code to know is group equals participant ID. That tells R, okay, when you're plotting these lines, treat each group as its own unit. So I just want you to draw a line from between the points that belong to each person. Another option that I think can work quite nicely in some circumstances is giving each person their own panel. You don't see this quite as often in papers. I don't think there's any particular reason for it, it's just that people aren't familiar with this kind of plot. But particularly if you have a manageable number of units, so you don't have like 1,000 participants that give you repeated measures, maybe it's a smaller number. This allows you to see really clearly each person's data. What's really nice about this is that you can focus in on each plot and see how different is the individual line for this person from the overall line across all people. And that I think is really nice. It gives you some extra information. So this is really kind of uncommon. It's very useful for looking at, like, do I have some people who are really weird? Because you can focus in on those people. So I think this kind of plot is quite nice. This option is often called having small multiples. Small multiples just means I have one plot that has a common format repeated a bunch of times. There's a handy bit of, again, ggplot code called facet_graph. There's another related function called facet_grid. Facet graph just says, okay, look at each chunk given by participant ID, and then create a plot for each participant ID. So I think this plot is quite nice too. For writing about these kinds of models, there's one major consideration, I think, and that's whether to talk about your results in terms of difference scores or in terms of this thing that I've only touched on somewhat called the linear mixed effects model. I think often for readers, the difference score version is easier to understand just because people are more familiar with the difference scores that are a little bit easier to think about. So this part right here, where I'm describing what the model is, that's where I describe how did I calculate the difference score and then how did I treat it. There's a second way to talk about this, which is in terms of linear mixed effects models, where the section where you're talking about the model setup ends up being different and a little bit harder to understand, I think, at least in some contexts. So you have to talk about the coding of the variable, even if it's just minus a half and positive half. That's sort of taken care of by default if you're just taking difference scores. And you have to describe the random effect structure. So often the one kind of terminology that you often see is talking about iReviewer. So iReviewer just says this is the unit that I use to break apart my data set into all these different chunks. Random intercept in random slope. But notice the rest of the text around it remain the same. So this is more about, I think, how you describe the model setup. just to give a quick summary, you don't always have this choice about whether to do something with repeated measures or not, but often you do. And if you do have the choice, the things to ask yourself are, what are the trade-offs that I make for each kind of design in terms of my construct validity, my internal validity, and my conclusion validity. And often, what will be the case, but not always, is that the repeated measures design will have higher conclusion validity, and you're asking yourself the question, well, is the hit that I take to construct and internal validity too much that I'm not willing to use repeated measures? All right, thanks very much, and I'll see many of you tomorrow.
Patrick, is there a drill on Friday still as well?
Yes, I'll double check with Austin, but what's up?
He told me yes.
Okay, then yes, still drill on Friday.